Today we will be discussing about Boolean expression using NMOS. Basically this comes under logic families, so something called logic families. So there are different types of logic families, TTL logic and transistor logic and MOSFET logic. So I am going to discuss about this MOSFET logic. So what is NMOS here? NMOS means N channel, N type MOSFET. So first we will design inverter. We will be designing one inverter. Inverter means what? Inverter means if a logic gate if I do, then the inverter looks like this. So if you give input as 1, then the output will be 0. If you give input as 0, then output will be 1. So we have to understand that in logic families or Boolean expression, we can understand that if the input is A, so if I write here input and if I write here output, so input is A, output is A bar. If input is A bar, output is A. Okay. So in this case, the thing is how to give this input in the practical circuit. So basically 1 represents your plus 5 volt and 0 represents your 0 volts. So if in the input side 1 volt, 1 logic I have to give, then I have to give as plus 5 volt. If I have to give logic 0, then I have to give 0 volts. So let us see how we can implement this NOT gate. This is also called as a NOT gate or an inverter. So this is also called as the NOT gate. So let us see how this can be implemented. So first what we need? We need a NMOS. So I'll just draw a diagram of NMOS here. Then we'll be seeing how does it work. So if I draw the NMOS, then this is how it will look like. So this is my drain, this is source and this will be your gate. Okay. So how does this MOSFET work? Generally, if I give one voltage here at the gate, then the channel will be created and from drain to source current will be flowing. So let us understand, if I give gate means some voltage at the gate, then how this NMOS is going to behave. So let us consider that I give plus 5 volt in the gate side. Then what will happen? So if the plus 5 volt is given to the gate side, then what will happen? Here there will be a conducting path. So if there will be a conducting path, I can represent that as a short circuit. Now what I can do? So I can draw the circuit something like this. To be simple, so this is drain and this is source. I am not drawing the gate here because if gate voltage is given 5 volt, then this drain to source they will conduct. And what will happen? They will behave as a short circuit. That means whatever voltage or potential is applied here, so that will be directly going to the ground which is connected to the source. And in case 0 volt is given, then what will happen? So this drain to source, they will behave as a open circuit. Why it will behave as a open circuit? Because if 0 volt is given in the gate, then there will be no channel created. So if no channel is created, that means drain to source current will not flow and it is behaving as a open circuit in this case. So when the ground is connected to source and if the potential is applied here at the drain point, then the potential will not go to the ground. Now let us see how this concept can be used to create a NOT gate. So to create a NOT gate, what I need? So I'll first draw the truth table for that, then we'll see that how does the truth table will work. So what is the truth table? Basically we have a input that is A and we have a output, let us take that as a F or the function. So if input is 1, output is 0. If input is 0, then output is 1. We want to implement this logic in the NMOS. So how to do that? So first I will draw the NMOS here. So this is my NMOS and this is for the NMOS, this is the drain side. So this is the drain side and this is my source side and this will be my gate. So my input is given at the gate, that means A is given here and the output is collected from this point, this is my F, or sometimes it will be written as V out as well. Okay, so here it will be written as V out because in the output we are going to get a voltage. So now the thing is that from where the voltage is coming, so 1 plus 5 volt will be connected to the drain side. Okay, now let us see understand the operation of it. So let us consider the first case where the input is 1. So what I said, if the input value is 1, we have to take plus 5 volt. So if you take plus 5 volt in the input, so if I apply here plus 5 volt, then what will happen? So this will behave as a short circuit for me. Then what will be the circuit? I can represent the circuit as plus 5 volt is given here. So it is plus 5 volt. So plus 5 volt is given here at the drain. Then the drain behaves as a drain to source behave as a short circuit, and then from the source it is grounded. The circuit is like it is grounded. So this side is source, and from where we are taking the output? We are taking the output from here, that is F, or we take this as V out. In this case, you see what is happening? The plus 5 volt is given here, but no current will flow to the output because it is already grounded, or there is a shortest part for the current. So what will happen? In this case, no current is going there. That means we are getting the output as here 0 volt. So what we got? If I give plus 5 volt as the input, that means if I give one input, then I am getting 0 as the output. Okay. So let us see the second case. So if I give the input as 0, then what will happen? So if I give input as 0 volt, then what will happen? This drain to source will now behave as an open circuit, so there will be no path for that. So now for 0 volt, what will be the equivalent circuit? So plus 5 volt is here, and then the drain is here. This will behave as an open circuit. So this is drain, this is my source, this is short circuited, and then the output is taken from the drain side as F or V out. So in this case, see what is happening here? The 5 volt that is applied at this point, so because this is a open circuited, so the current will not flow here, and the current will be observed in the F point, means the potential will be available here. In this case, the value of V out, or the output voltage, will be plus 5 volt. Okay, that means we are giving 0 as the input and we are getting 1 as the output. So why I am saying 1 as the output? Here you can see, if plus 5 volt is there, that represent as 1. So that is how the NOT gate can be implemented using your NMOS. Now this is the logic, or this is the concept of how does the NMOS work. Now the actual circuit is something different. So let me just draw that circuit. So there will be a plus 5 volt, and this will directly not go to the NMOS that is used for the logic gate. It will pass through one another. So this will pass through another MOSFET, so that is called as your load MOSFET. So this is called as your load MOSFET. So though for operation, understanding the operation, it is not important, but for the circuit point of view, it is important. So see, the gate is connected directly to the VCC, means gate is connected to plus 5 volt. So that means there is always a path for the current, means the plus 5 volt will reach at this point. Then what happens? So here another MOS will be connected. So that is my inverter, that will work as my inverter here. So this will be your gate, this is your F or the V in we say, and from here we take the output or the F. So this will be your V out, and this is your F. And for the second MOSFET, so this point is D. For the second MOSFET, this point is D, this point is S, and the source is grounded. So like this, the NOT gate can be implemented using your NMOS. So in the next video, we will be seeing how NMOS can be used for NAND gate.